Can I keep a processor cool just by blowing air straight at it, no heatsink? And my victim is going to be this Geekom A9, which uses a Ryzen 9 CPU. So before I potentially break this thing, I want to compare it to my Intel i9 processor to see how it does. This one's got the Intel i9 and this one the Ryzen 9, and both of these run off of a power adapter like that. And I'm going to measure the power using these TP-Link switches. And to make sure I'm fair, I'm just going to use a dummy load on either of those. 80 watts, and on the other one, 80 watts, so I'm good. I'm going to run a simple single-thread benchmark on both of these, and I'm controlling the A9 just with remote desktop from the other computer, and I'm measuring the power of both of these here. So I'm seeing the Intel draw quite a bit more power than the AMD. So I got 45 seconds on the Intel with 1600 joules of power consumed versus 41 seconds on the AMD with just 959 joules. So what's interesting, on the AMD, my power consumption varies a lot more than it does on the Intel, and I thought maybe it's just some regulation type thing happening, but if I run my same test suite again, I get exactly the same power profile, and then I skip these first few tests that use less power and it goes right to this part here. So the AMD, depending on what the computational load is, will use different amounts of power, whereas the Intel does not. So my guess is the AMD is much better at shutting down unused parts of the CPU in a rather fine-grained fashion compared to the Intel. And I just repeated the test with two instances of it running at the same time, and they both slowed down even though I'm only using 2 cores, and that's just thermal throttling issues. Although the speed gap has actually widened a bit. This one is more than 10% faster now. Now my i9 has got 6 performance cores, whereas the Ryzen 9 has got 12. So let's run 6 instances to give this one the best chance. And with 6 instances, the AMD actually used more power, but it finished the job 20% faster, so the net energy consumed was still a little bit less than the Intel. And then I reran it with 24 instances to make full use of all the AMD's hardware threads. And the AMD settled in at about 70 watts power consumed versus about 53 watts for the Intel, but the Intel took 1.6 times longer and still used more energy in total than the AMD. And the name of the CPU in here has AI in its name, so it's supposed to be good at that. So I downloaded LM Studio and I just asked it a question. Right now it's in the thinking phase of answering how many angels can dance on a pinhead. And while it's doing all that thinking, it's drawing 75 watts of power. And here comes the answer. So the speed is not too bad, and accuracy is not as good as ChatGPT 5, but better than 4 was. So every time I've seen people talk about LLMs running locally, they always have some massive GPU, so I'm kind of surprised that this little box can run AI in a reasonable manner, but I have no experience with this sort of stuff. Although with an earlier query turning max reasoning on, I got it thinking for a full 9 minutes and 34 seconds before it started spitting out an answer. A very good answer though. So now that I've got that out of the way, time for the risky experiments. So this Geekom A9 Max is not as upgrade friendly as the earlier ones like the IT13 that I was testing, or the A5, which is the same layout. So there's quite a bit of space in here. There's even room for a regular hard drive in here, whereas here there's no space, and that's because so much of this case is just a cooler, whereas on here the cooler is much smaller, leaving more room. And I also accidentally pulled the Wi-Fi connectors off the Wi-Fi card, which is down there. Very difficult to get back on there, but that's okay. I haven't been using Wi-Fi because my router is buggy and crashes with the Wi-Fi on this one. So this has got a very nice machine case. I guess they're trying to be like the Mac Mini. It's also the exact same size, but of course I care more about this part here. And that's a pretty massive cooler for a mini PC, and you can see how it takes up more than half the space inside of it. And except for the Wi-Fi antenna, everything is attached to this PCB. Whoa! So we've got a whole lot of heat pipes that take the heat from the chips over to the heatsink. I'm not sure what's underneath here. I want to watch those heat pipes in action with a thermal camera, and this is the top-down TC0002 Duo, and this one works with iOS on my iPad, on my Android phone, and it can plug straight into a PC. And let's put some heat where the CPU is. And we can see how the heat is just flowing along those pipes towards the heatsink, which is already warming up. Let's do this part here too. And it just goes straight across to here. But let's get rid of all that cooling stuff. So it turns out the other components that the heatsink touches are these resistors, which are marked R10, which by my understanding means 0.1 ohms, which is what they measure at, but why those resistors? I don't know. So I was going to clean off the rest of this heatsink grease on here, but actually I think I might add more to it for now, because the problem is this whole chip here is infrared reflective. You can see the reflection of the heat from my hand. The grease not so much, but the metal around it definitely. So I think I might add more grease to make it all infrared opaque so that I can see the heat on it better. Got the grease spread and the board hooked up, ready to run, but I'm pretty sure this will overheat before it even boots up. So some kind of fan, but I don't think this is strong enough. So I'm going to use a blower from a broken dehumidifier. At least this one is quiet. And that's heating up really fast. 50, 60 degrees now. And it looks like we're booted. So according to the infrared, the temperature's back down to about 26 degrees on the CPU. We're booted, and we're down to 4.5 watts drawn. Maybe 5. And now running that single-threaded performance benchmark. And power is perhaps lower than it was before, probably because this thing wants to avoid overheating the CPU, although this says only 56 degrees right now. So this is now 15% slower than it was with the heatsink, but also consuming less total energy. And the power consumption is pretty constant because the CPU is basically throttling itself by temperature, going for about 16 watts on average. And now running with 24 instances, power consumption is up to about 25 watts. I guess that's as much as it can tolerate. CPU temperature, according to infrared, is 64 degrees. And that took long enough, it doesn't fit on my laptop screen. So looking at that on my big desktop, that took more than twice as long, 76 seconds before, and it also used about a quarter less energy. And the power consumption initially shot up, but then the CPU got hot, and then it just regulates the whole thing at an average of about 25 watts through the whole run. So I'm doubting the readings I'm getting off of the thing here. I think the emissivity of this is not quite what I expect it to be. You can see it reflects the infrared from my thumb. So I ran this core temp utility, which unfortunately stops running when I'm running my benchmarks, but immediately after stopping the benchmark, it got up to 90 degrees. So I'm guessing during the test, that CPU is probably about 100 degrees, which is kind of getting marginal, but still okay. I also noticed there seems to be this throbbing in terms of temperature, and I wasn't sure if that was the camera or whatnot, but if I take this tool and exit it, the throbbing goes away. So that is basically CPU load from my temperature monitor tool. And the airspeed from my blower is about 12 meters per second. Now this blower blows way harder. 38 meters per second. I made this to direct the air down at the CPU, but there's a slight problem. So looking at this in infrared, there's a warm spot where the air comes out, and that's because the air gets warmed up in the blower. It gets churned around so hard that it's actually a little bit warm coming out, about 5 degrees warmer than ambient. And running this one looks about the same, and power consumption is only a little bit bigger than it was with the other blower. And looking at the power graph, despite the greatly improved wind speed, my power consumption is only slightly higher, which is to say this is cooling only a little bit better than the slower blower. And then I tried blowing the air at a slight angle, but no improvement. And finally with the heatsink grease removed, but again, no improvement. And now with the heatsink back on and the fan, it's blowing quietly and is able to dissipate 70 watts. So way better than my noisy blowers. It really is amazing how well these heatsinks work compared to just blowing air at the CPU. And I know I'm putting it back together, so the Wi-Fi antennas are attached to this plate here, and the only way to get this plate in without pulling the cables out of the sockets is to take this antenna off, because the cables are just too short. So if you upgrade the SSD or the RAM in this thing, that's something you need to know. I went back and looked at which tests the Geekom A9 consumed less power at, and it turns out those are tests that it does actually relatively poorly, at least compared to the Geekom IT13 with an Intel i9 processor. And those actually are also tests that are designed to trip up the pipelining in the processor. And this Ryzen 9 has a rather long pipeline based on some of my other tests. I'm not looking at any specs, just looking at how it behaves in my tests. So credit to it for not wasting electricity on parts of the pipeline it can't use at the same time. And by doing poorly, I don't mean so much that it does badly, it's just not ahead of the IT13, which has got an Intel i9 in it. And for some of my heuristic tests, the single core performance on this one is about 25% better. And if I'm running all cores flat out, it does about 1.6 times better than the Geekom IT13 with the mobile i9 processor. So it's definitely a step up in performance. And if you'd like to buy one, it does cost more than the Geekom IT13 mini PC, but there's a promotion on right now. See links in the description.